transformation and publication of marine biology, marine diversity data using Darwin Core standards. And to me, it means develop a Python auto pipeline converting random biodiversity data into Darwin Core standards. And a bit about me. I'm Ella from UQ. I have a dual degree in Math and Comp Sci. I've been working as a uni tutor and software dev before this, and I have a list of hobbies. But as you can see from what I've done to the project, there's a bit of knowledge gap, and as a result, I have problems. Firstly, what's Darwin Core? No idea, so I did a course on that. It's an international standard, which we have event core or occurrence core, where event core focus on what happened. You went on a voyage, or you sample what, and occurrence focus on what you found. So these are the species that occurred. EMOF, that's kind of an attachment that can attach on either an occurrence or an event to explain more about it. And there's another table called eDNA, that's also an extension. That's when all the DNA data is involved. And Darwin Core Archive is a core CSV surrounded by a few extensions, where the extensions are linked by foreign key. And 2 meta files, 1 meta XML telling you what's in the archive, and 1 EML telling you about the source. So who's the author, when was it last modified, things like that. Together, you zip them together in archive. So we know what our goal is. All we need to do is map from the random data we got to Darwin Core, right? We can try to check if it's Darwin Core Archive already. If it is, we're done. Check the actual content of the column to look up worms to see if it's a scientific name. If it's a date or WKT, which is a standard for coordinates, you can pattern match it because it will look like that. Or use synonym. I use the library disperse to map the column name to Darwin Core standard terms, and generate core ID, which will be the primary key if it's missing. But doing all that, all I can do is narrow down the selection, not to a precise column. And due to my trust issue to the big language models, we need manual selection to precisely select which one. So this is the interface. It's guided by all these steps, but it's up to human to pick one or do a search or manual entry. That's the transformation part, but what about publication? This is the graph that the ship sent me. We are here Office AU. We get the raw data and process it, put it into database, publish it to Office and GBIF. And these two, but I wouldn't talk much about them. And this is the current workflow where we have the raw data, run the Fusion code manually, convert it to Darwin Core standards, put it into the database, and then do the quality check before publish it through IPT to these two. And this is the goal where we run Python modularized automatic pipeline, convert it to Darwin Core, do the quality check before going to the database, and package it as a Darwin Core archive that can be sent to a third party without having them interacting with our database. Okay, then what is modularized automatic pipeline? I was told about Dexter, which is a purple octopus thingy. What's Dexter? I did a course on that. It's an orchestra, which is a tool that can manage and coordinate complex workflows and data pipelines. And a workflow is a system managing repetitive processes which occur in a particular order, or in another word, adapt, which has lots of good property. So each color, like from turtle raw to turtle validated data, that's a pipeline, and a April mapping is a separate pipeline. And they are grouped by stages as well, as you can see the box from raw to QC, stand for quality check. And the one I use is asset-based, which means that each node on this graph is an asset. It's like a product or a middle product of the pipeline. And this is the Dexter workflow I developed. Start with downloading job. You can schedule it weekly, monthly, up to you. You download the raw data, pre-process it, optionally run a pre-processed script if one is provided, and produce the Darwin call mapping telling you which column map to what. The mapping job, it's a sensor that waits for the Darwin call mapping CSV, trigger the rest of pipeline starting with map data, and map Darwin call to Darwin call terms according to the CSV, and clean up and complete the table as much as possible. Then we move on to auto QC, do the now check, bound check, and give a metric score in terms of how good the data set is, and produces graphs for numerical columns. The validated data that we copy meta files from raw data if they are provided, and then look at the directory to check the meta and EML or generate one if they are not provided. Lastly, we zip it up to produce an archive as well as a PDF QC report that's human readable, so that human can look at it, resolve the null value, and look at the graphs to identify outliers. I've written like Python script for each asset, tested them locally, they work. So you will think, how hard will it be to put them together into Dexter? That's running a huge main function, right? But it's a bit harder than I thought. The solution I had previously, having human manual selection, is causing problem. At this step, to produce a Darwin call mapping, we need human interaction. And Dexter is in fact non-interactive, which means that it no like human input. I stuck on it for days, but this is a solution I came out with, having a parent, having a student in terminal as a child, and the parent is busy waiting, so it's non-block. It's waiting all the time, and to use it, you open the master, open the reading as TTY and read line to get the user input from the child, from the pseudo terminal. The only functionality it's missing right now is I have no idea what user is inputting until they hit the enter. So the autocomplete is gone. When you are searching up a term, you have to type exactly what the Darwin call term is. It's annoying, but it's working 80%, I would say, and I will settle for that for now. And this is the report I generated. You have like the bounding box, analysis, the quality, how good it is, followed by lots of plots in terms of the distribution of numerical data. Like this one is decimal longitude, you probably can't read, but yeah. And human can be like, oh, this is an outlier, we probably should fix that. And having the pipeline means that it's reusable. After human fixing it, you can send the package through the pipeline again and get a new report to see if it's good enough to go into the database. Alright, that's my project and my experience. This was orientation week. I taught the quiz, so I got a $25 book voucher. I haven't used it, so any recommendation, bring it on. I graduated. That's my grad photo in front of investigator. It's kind of important. And I personally used the investigator 10 years party as my grad party. Speaking of investigator, I went on it twice with IDC and the rest of the, yeah, you guys basically. And I've been living out of van for 3 months, hiked a lot. Went on 11 hikes, 10 different hikes, did Walls of Jerusalem twice because it's my favorite. 5 of them are multi-day, red paints, and 6-day hikes. A total of 287K. And further down, that's Cape Rao, Cape Pillar, my favorite hike at the time. The well I saw at Cape Pillar, I was on top of Pillar, so that's super zoomed in. on Cradle Mountain. It was so rainy. Like I couldn't see a thing when I go up the peak, but this is like halfway up at the Wombat Pool, I believe. This is Bruny Island when I was waiting for little penguins, but I didn't see any. What I saw instead was bioluminescence, which is cool. Mount Field. It was rainy for 2 days, and as soon as I got out of my multi-day hike, it cleared up, so I went back for the West Peak and the K-Cap track, and it's just enough cloud for the lights to shut down. It was brilliant. This is actually at CSIRO car park. I believe they are racing, but I don't know for sure. This is Southeast Cape, which is like the southeast part of Tasmania, and I was light painting. That's how I spell Tasmania, by the way. That's also Southeast Cape. That's a self-portrait of me. This is Shipyard, all-day parking. I came there overnight. That was of Jerusalem, and yeah, that's my tent, and I just opened up to the wall, I guess. Also was of Jerusalem, a bit of light painting. That's like, it's 1 degree overnight, so lots of star jumps were involved. Mount Jerusalem, full of flower and a rainbow on top. I woke up in CSIRO car park maybe midday, and birds are feeding off fish. That's like straight out of my bin rear gate. That's Jan 1st aurora, followed by some storms. I dashed there like it's maybe 15 minutes from my bin, and I heard the thunderstorms, so I dashed there to grab my camera. This was 2 weeks ago with the Boats Festival, and that's One Glass Bay. And you can see the water, it's about sunset time, the water is actually a bit red. So I guess that's why it's called One Glass Bay. And at the end, special thanks to my lovely roommate and IDC team, especially Sashit and Kath. You are giving me like all the support I can ever ask for. So yeah, really guys.
Thanks, Ella. Those are fantastic photos, and again another fantastic piece of work where you had to learn a lot and did an impressive amount of work after having to learn all those skills as well on the job. So that's excellent. Do we have questions for Ella?
I guess if there's no questions, I'd like to say how much we value what you've done, because you've taken something that requires a lot of manual intervention and human checking, and taken every part of it that can be automated and automated it. And as we move towards publishing the biodiversity, the data that comes off the investigator, and especially the eDNA data that's starting to come through with the automated eDNA sampler, everything we do is going to be implemented into our business as usual operation. So you've changed our lives. Yeah.
I'd like to add thanks for the amazing work and for laying a foundation for the building the automation in what we do. So we have published around more than 13 billion records, occurrence records, and more than 500 data sets. The issue was for each data set we have a separate script, and we have to run them manually. But using a Dagster, we can automate the process. We can schedule the transformation and publication process. So all thanks for your amazing work.
Thanks.
And also you have added more the report generation for what we did, for transformation and publication and the validation. So without that, the value. Thank you.
Great. And do you have a few more days left, or when do you finish?
I'm leaving Thursday, so soon. 2 days left.
Which actually then reminds me, tomorrow lunchtime, early lunch, Tanya and Ella and some people from the IDC and I think a group of other students, and we'd like to invite anyone else who's keen. We're going to walk up to Jackman and Macross, get takeaway lunch, hope the weather holds, and sit in the park across the road and have a celebratory picnic lunch. So if anyone would like to come, tap Ella or Tanya for the invitation, or send me a message. You can know my email address and not theirs, and I'll forward it on.
just like to say again, thanks to all the students and all the supervisors as